Welcome back, everyone, to the tier module of our workshop today. Just a quick recap of the way we are handling questions for anyone just joining us now. If anything comes to mind, please use the Q&A function that is built into Zoom. So all the questions can go into a queue, and we will answer them all at the end of the talk. My name is Hernán, and the idea is that I will walk you through today with a live demo on how we can create tables in CrateDB, get some data loaded into these tables, and then run all sorts of different queries to explore a bit what are the capabilities that we got on CrateDB at a very basic level. I will try to both cover the basics in case you are new to CrateDB and new to SQL in general, but also give some advanced tips and tricks. So if you are already experienced in CrateDB or with SQL databases in general, I hope you will still find this interesting. The first thing I will cover is how we can create some tables. And let me go straight into a live demo for this. I will be using some sample data that I got from Kaggle. This is data about some customer details for an imaginary shop. And here I got a test environment, a single node CrateDB instance. This is the admin UI web interface that Niklas mentioned earlier. You get this out of the box as soon as you deploy a CrateDB node, and it allows you to monitor everything that is going on in the cluster. You can get lots of detailed information. We will see a few basic things later on. And most importantly, you can also use this to run SQL commands against your CrateDB cluster. We could use all sorts of other Postgres compatible tools like dbeaver, which I will be showing later. But this is very handy because it's built in. You don't need to install anything. You just browse one of your nodes on port 4200, and you can immediately get started running commands. And to import that data about the customers of that shop, we will need to create a table. So here I got a sample command to start this discussion. And as my colleagues mentioned earlier, one of the nice things about CrateDB is that you interact with it with a standard SQL language, meaning that you can bring over to CrateDB all the knowledge that you already have of the SQL language, all sorts of scripts that you may already have to create database schemas in other systems. You can reuse all that when you come over to CrateDB. And here we see that we will be creating a table called customer data, and there are a number of columns. Each column got a data type. We got some numeric data, some strings, and all this you can see on the surface looks exactly like it would on a relational database like Postgres or MySQL. But there are many interesting things going on here. One thing is that you don't need to worry about the topology of the CrateDB cluster behind. There could be 50 nodes. They could have any different combination of storage classes. There could be all sorts of things going on. As a developer, as someone looking at the schema, creating tables, you don't need to be concerned about that if you don't want to. We got lots of advanced options that you can go into if you want to tweak and optimize things. But you can also very simply create a table with a command like this. And don't worry about indexing, don't worry about sharding, or where the data physically gets stored. Here we are defining already some data types, and I invite you to review the link that my colleagues posted on the chat with a list of all our different data types. being a multimodal database, we support geographical information, we support embeddings, we support arrays, we have special data types for things like IP addresses, all sort of very interesting options there. And we also got a container data type called object that you can use to store things like JSON payloads that you may get from third-party APIs, from sensor data, and so on. So you can get this unstructured data into your table, into a column. You may have also heard my colleague Maria mention dynamic schemas earlier, and you may be wondering why I bother on defining the columns here. And that's a valid question, which I get from time to time. You could also go on and don't define the columns in advance, and you could still import the data, and CrateDB will infer the data types. And there are very good cases where you may want to do that, or where you may want to go the traditional route of defining the columns in advance. In general, I find that works very well for things like an object column where you get data from a third-party API that you don't control. Maybe all of a sudden they start adding a new field. If you have that dynamic schema there, the new field is accepted. CrateDB recognizes the data type, indexes the data, and nothing breaks. Everything continues working, and the data is immediately available for you to query. When it comes to more traditional tables that you control, defining things manually gives you more flexibility on the data types. You may make more optimized choices like the ones we are going to make now. So I wanted to show you just a few things that you probably know already if you're familiar with SQL, but it's good to review quickly. We can do things in CrateDB like we would on any other, like we would on any relational database. Lots of NoSQL databases don't allow you to do things like this. We can do things like define a primary key, for instance. So we can say this customer ID needs to be unique. Each entry on the table needs to have a unique customer ID. And very simply, by defining this column as the primary key, CrateDB will take care of enforcing that. We can also do other things like defining a default value for a column. So for instance, here we got this score column. And if we think about it, if we don't insert a value in there, when we retrieve the record, we will have a null value, like we would on a normal relational database. But when you are building reports, sometimes this is inconvenient because you need to handle the case where you got a null. So it is handy in this case to define a default value. We can say that if we don't specify the score, the default should be 0, and that we don't want to send null values. So even if someone explicitly passes a null, we won't allow that. Just by adding these few keywords in the corresponding line for the column, CrateDB takes care of this. Another thing you may notice here is that we got, for instance, a column for the age of the customer. And we know people, unfortunately, don't live thousands of years. So what we can do here is we can create what is called a check constraint. So just by adding the keyword check and then any valid expression, we can say, for instance, that age should be less than 150, for instance. So this way, just by writing that there, if someone tries to insert a value that is above 150, the insert will fail, the record will be rejected. And all this, we didn't need to build some complex logic about this. We didn't need to manage this on the middle tier. The database can already enforce this. We spoke about data types and the importance in some cases of controlling that manually ourselves. This could apply, for instance, to the family size. If we were to just insert data in here, numbers may come in 2, 3. CrateDB will say, okay, it's a numeric value, but it wouldn't immediately know what the range will be. So knowing that it won't be in the millions range, we can ourselves already go ahead and define this as a small int. And this way, for every record, we will be saving a number of bytes. When you think of time series data where tables grow into the billions and trillions of rows, these savings build up, and they can make a big difference, and not only on your disk space consumption, but also on the load of the system, as there is less activity on the disk, less memory consumption, less CPU cycles to deal with all that. And you can improve performance significantly by just paying attention to a few things like this. So before we move on, I just wanted to mention very quickly one more thing. Here, after the list of columns, we can specify a width clause with a number of options. We can also specify things like sharding options, partitioning options, and all those will be covered into more detail on the next modules that we will have tomorrow. But very briefly, just wanted to mention one setting that is called number of replicas, because by default, CrateDB will, if you don't specify this setting and you got a multi-node cluster, CrateDB will keep one copy of all the data, and that allows CrateDB to continue operating even in case you lose any node at any time. So if any node has any kind of issue, and this can be an incident, or it can be that maybe you are just restarting the machine, for instance, CrateDB will still have a copy of the data on another node, so it can continue serving all your queries. But this is optional. You can decide to have more replicas, and therefore be able to sustain, be able to still serve all queries when losing more than one node at the same time. But you can also do the opposite, like in this case, and say, I don't want any replicas because maybe it's low value data or data that you can easily recreate, and you prefer to save this space and don't have to maintain any copies. So yeah, that was just one setting that I thought was interesting to mention. And I think I had spent enough time on this already. So let's go ahead and create this table. Perfect, table created. So now I want to show you here on the left-hand side, there is this tables view where you will see this table that we just created. At the moment, it got 0 records. We didn't specify sharding options, so CrateDB decided for us in this case, to go for 4 shards. Here we see all the columns that we specified. We see data about this space consumption. And if we will have a partitioning, there will be plenty more details here, and we'll see a lot of other interesting things. But just wanted to very quickly show you that there is this tables view here. Going back to the console, another trick that you may find interesting is the show create table command. By running this show create table command, you can get back a SQL script that will create a table with exactly the same options that you got on this environment. So you can take this script and put it into source control, or bring it to another environment. Maybe you are working on your machine developing, and then you want to deploy this into a test environment, into production. You can take the script and run it on the other environment, and be sure that you are getting exactly the same settings. Let me go back to the slides very quickly. Yes. So we cover the creation of tables. I also want to mention that another very nice thing in CrateDB is that you can backup and restore tables individually. So you don't need to take an entire database and restore all of it from a backup. You can go and be granular, both when you do the backups and when you restore. You can do individual tables and also individual partitions within the tables. This is very handy when you are trying to troubleshoot and to debug an issue in your application, for instance, and you got the production database that may be huge, maybe 20 terabytes large, but you only need some specific data to work on it on another environment to debug the issue. So you could just take the relevant partition and restore just that in the other environment. Also for disaster recovery scenarios, instead of having to wait for all the data to be restored, you can just restore the partitions for the current data, for instance, get your users back online, and then behind the scenes continue restoring the older data, all the historical data, but the business is back in operation. You don't need to wait for all the data to be restored. And now that we got a table, the next thing will be to load some data into it. There are many different ways to do this. And the first thing I want to mention is that if you are using our fully managed CrateDB Cloud solution, you will find directly in the Cloud Console options in the web interface to import and export data. So if you got Parquet files, JSON files, compressed files that have this kind of files inside, they may be on your own machine, they may be on an S3 bucket. You can just follow the instructions on the screen, and with a few clicks, you can get the data imported without writing any code at all. And we will share a link on to a tutorial that covers this aspect. The other way to do this is with SQL commands, of course. So let me go back to my test environment here. And we will very briefly and very quickly do an example. So standard is insert into command. We run it, we got a record in. This very trivial example, but we support the full flexibility of the SQL language. So here you could be running a complex select that combines data from other tables. You could be passing, of course, multiple records in a single statement. We support returning clauses, all sort of things here. Also for those of you that are more into programming, we can do prepare statements, so you can do your batches and do bulk inserts in a very efficient way. And another way to import data is with our copy from command. The copy from command allows you to import data from files. There are a few things to mention here. The files need to be accessible to the CrateDB server. So in this case, for instance, that I am telling CrateDB to import from this path here is not a path on my local computer. It is a path on the CrateDB server. The same if I will be referring to an S3 bucket, for instance, an HTTP address somewhere on the internet. It's not my machine that will go to this location, but it's the CrateDB servers that will do it. So you need to consider this when you are building your environment to allow the connectivity for this to work if you will be doing this kind of data import. In this case, we already got the table. There is this CSV file, and I will just run that command, and we will see that I got 2,000 rows imported. The nice thing about this command is that there is a lot of logic that is taken care of for you. And for instance, if in this case, I am importing from the local file system, but if I would be doing it from a network location and there were any sort of temporary network glitch, copy from can automatically resume importing, can back off and speed up depending on how the connectivity speed is working. So all that is taken care of for you. Also, if we will have some tricky situation where maybe some records in the file have data types that don't match what is on the table. Let's think, for instance, of that example with the age, where I configure a check constraint limiting the value to be below 150. Let's say on the file there would have been a value of 200, instead of stopping, it will continue importing the remaining records, and it will just list all the errors that occur here for me to review at the end. So all that is taken care for you, and we just needed a very simple command. Also, if in the future there are performance optimizations or anything like that, you benefit from that right away. So it's quite an interesting option to consider. But one thing I need to mention is that it's not the fastest way to import data. It is designed to not overwhelm the cluster, to allow this to work in conjunction with your dashboards, to allow all other people that want to use the cluster for other things to continue working at the same time that you do this. If you are looking at taking as many resources as possible to complete this import as quickly as possible, then it's better to take another route and do a bulk insert. Just wanted to show you very quickly that the data got indeed imported. And here we see our table with some records in that. So let's go back to the slides very briefly. The next thing I want to mention is how you could get some data inserted programmatically from a programming language like Python, like in this example. And we will be sharing a link to this list of drivers that we got. In general, you can use any Postgres compatible driver to connect to CrateDB. So if you already got some code, some logic that uses a Postgres driver already, or can easily be switched to use a Postgres driver, then that's the easiest way to connect, and it will work. But there are two interfaces to CrateDB: the interface through the Postgres protocol and an HTTP interface that provides also a bulk insert interface that is the fastest way to get data into CrateDB. So if you have the choice of driver, we provide drivers for a few programming languages that are optimized to use our HTTP endpoint. And there you will find commands to do this kind of bulk insert that I was talking about. So I want to show you very briefly from a Jupyter notebook here. I will be running some Python code. This using our Python client. And here, very trivially, I will just get two records inserted. And we see that went through. So if I go back to here and I say, well, customer ID, that was 3001, 3002. We can see that the two records got inserted. And of course, this being Python, you can use pandas, you can use TensorFlow, you can use any of all the nice packages that are available in the Python ecosystem. You are not forced to use Python. You can use all sort of languages to connect to CrateDB, but Python is very popular, so I wanted to mention in particular. And here I got another example with pandas, where we can go and retrieve some data from that table from before. And please don't mind the execution times, because it's all running on my laptop at the same time as Zoom is running. So, but you can see that we can connect to CrateDB, we can get data in, we can get data out. It's all very straightforward. No need to write anything complex. It's just the same syntax that you will use with other databases, with the SQL language, of course. Let me just go back to the slides very briefly. The next thing I wanted to cover is a bit more about the admin UI and the things that it allows us to do. So first of all, here on the console, there is a history of queries maintained. So if you position yourself on this frame here and you just press the up arrow or the down arrow on your keyboard, you will see that we can move between the commands that we ran previously, which is very handy in case you need to do any minor changes. You can just recall the previous command and make some adjustments and run it again. Another thing is that we can it's all the formatting that the admin UI does when it shows some data in here. So, for instance, if we got some system tables in CrateDB that are always available, like this sysnodes table. And I mentioned earlier that one of the data types for the columns can be object. This table got a lot of objects in there. When you get an object, you will see that you can click on it and it will display what is inside the object. Let me see if I find a more interesting example like this. Here you see that we got objects within objects. We can do that. This can grow to huge levels of complexity. You can have arrays of objects. It can get as complex as you want. So here is presented in an easy to read fashion, but if you want to see what this looks like in a raw format, you will see you got this JSON in there, but when you query it from the admin UI, you get this nice visualization. Also, you may notice this limit 100. I didn't write this myself. This is added automatically to all your queries if you don't specify a limit explicitly. And it's there just to prevent you from accidentally attempting to retrieve millions and millions of records from a huge table. So before you end up overwhelming the entire network, taking over a terabyte of data, it just adds this limit 100, but you can go in there and you can, of course, change it. And of course, we support also the offset clause, so you can adjust that whatever way you like. The next quick thing on this topic is that if you don't want to use the admin UI, you can use other tools, like I mentioned earlier. And in particular, I wanted to show you dbeaver. You may already be familiar with dbeaver. Maybe you are using it for some other database system. You can just bring CrateDB into it. And the interesting thing about dbeaver is that it has native support for CrateDB. But today, just for the purpose of doing the demo, I want to show you that we can pretend that it is a Postgres instance, and it will connect with our issues, and it will just work. And you could do the same with other Postgres compatible tools. So in this case, this is the IP address of my test environment. So we're connected successfully, and we can open a new SQL script window. Yes. I hope that's easy to see on your screen. Sorry, the resolution is a bit high, may not be very clear. So we can see here that we can query the table that we created earlier. And you may have noticed when I was typing this that the autocomplete kicked in and automatically filled the remaining part of the table name. And that's because CrateDB implements all the information schema tables as in a standard Postgres. So here dbeaver was able to take advantage of that, and it offered me all the autocomplete functionality the same as I will be on a Postgres instance. So here we saw that working. And my colleague will post a link on the chat where you can see a list of a series of different tools that we have tested with CrateDB and for which we got tutorials, we got articles explaining how to take advantage of the functionality in CrateDB with the different tools. You may find that very interesting. So now I just want to show you a few tips and tricks, a few different things that we can do with CrateDB. So, of course, one thing we can do is that we can run very quick aggregations in CrateDB because by default, and this is of course configurable, but by default, all data in CrateDB gets indexed. We get columnar storage for all numeric data types. That means that we can filter on any field. We can run aggregations of any fields, and everything is super fast. So, which is very nice. If you are a developer, you don't need to worry about the kind of indexes that will be needed. You don't need to guess what kind of queries the users may want to run against the data. You can just stick with the basics of defining the schema and write the queries, and then the users can get the results very fast. So, for instance, in this case, we are doing a count, we are doing a grouping, we see how many customers we got for each age group. Of course, we could do all sort of variations of this. For instance, see how many different professions, for instance, with account listing. It's a interesting trick if you haven't seen this before. More trivially, like we can do sums, we can do averages. Note also that you can do your group bys and order bys by passing the column names, but you can also do them by ordinal. So in this case, you can say by one. That will be the first column in my query. So that gives you a flavor of the kind of aggregations that you can run. These are very simple. I will come back to this with more complex examples in a few slides. So we covered group by. Just one quick note on group bys when you combine them with limit and offset clauses. When you specify a limit, like the limit 100, that limits how many rows are returned, not how many rows are processed. So you may have a huge table where there are millions of rows, but if you are grouping in a way that only 10 rows get returned, then the limit 100 will still return all the rows because it's processing all the million rows, and it's the result set that is limited to 100. I wanted to have a quick word about working with dates in CrateDB. So CrateDB internally represents dates and timestamps as an epoch. That's the number of milliseconds since the 70s. But you don't need to worry about it. It's just the internal representation. It just happens to be handy if you're migrating data from some other systems that use the same convention. You can use the numeric value when you do import and exports. But you can, of course, also use the directly annotation like this. And we got lots and lots of different functions that you can use to work with numeric data. For instance, with timestamp data. So, for instance, we got a function called datetrunc that you can use to truncate the precision of a timestamp to a less granular level. So, for instance, here I got the now timestamp. There is a function that returns the current date and time, and I am truncating it to month level precision. So that translates into the beginning of the current month. This is very handy when you are creating generated columns. CrateDB, we didn't touch into that, it gets a bit advanced, but you can specify expressions when you create a table, and these are computed automatically every time a record is inserted, and they are indexed as well. We call these generated columns, and you can use them for all sorts of things, including for partitioning. So, for instance, if you want to partition by month, you can use this kind of expression to do it. and my colleagues will cover that in more detail on the next few modules. But this function allows to truncate to entire month, entire day, entire year, but we can also do more complex bucketing, like with this other function called datein. So for instance, I can split things into intervals of 2 hours. We can split things into intervals of 4 days, for instance. We can start from a base that is not 0, so you can start at 5 minutes past the hour, whatever makes sense for your application. There is also another function that you may find useful, that is the extract function. So what we saw before with datetrunc and datebean is that they return themselves a timestamp, which is very useful because you can then take that and use it in other queries for do range filtering and stuff like that. But if what you're looking for is instead just the number that for the year, or the number for the month, or the hour, or something like that, then you can use this extract function instead. So that covers dates, I think. And the next thing I wanted to talk about is arrays. Arrays are quite interesting because CrateDB supports arrays natively, and lots of other database systems don't. So let me give you a few examples. Let's imagine that we got a string, like in this case, the string is A, B, C. We can convert that into an array with a function that we got called string to array. A string to array takes in a string and another string with a separator, which in this case is the comma, but it could be anything. And it returns an array. So here we see the result is an array with 3 elements. This array could go straight into a column. We can have a column of type array, and we can receive this input directly into the column. And if we got the kind of data into a table, when we retrieve it, we may want to do some other transformations. So one thing that we may want to do is break this down into rows. So for that, there is this very handy nest function, which has now converted the array with 3 elements into 3 rows, each with value for the element that was there into the array. Of course, we can also do the opposite. We can package results from a select multiple rows back into an array. So, for instance, here the expression is getting a bit tricky, but we got the string, we break it down into an array. So here we got an array, and then we use a nest, so we break it down into rows, and then we package the rows back into an array. So here you see we are back into the array. And when you got arrays, you can do lots of interesting things, like you can do comparisons between elements, like you can look for a value. If a value is inside an array, you can do slicing and substitutions of pieces of the array. You can also look for minimum and maximum values and do aggregations across the array. And these kind of things, these kind of objects can also be passed back and forward with user-defined functions. So you may have here that CrateDB can be extended with user-defined functions, and you can take all these sort of complex objects, pass them in input to user-defined functions, and also get them back on the functions. So there is all the flexibility to build really, really complex kind of things around this. Just getting towards the end of this presentation, I wanted to talk about joins. There was a question earlier about joins performance, and I want to show you how it works in CrateDB. You will see it works pretty well. So for that, I will first go to this other cluster that I got here where I got more data. We can do a better demo of this. So here I got a query. There are 2 tables involved in here. There is a table about power consumption. So there are electricity meters and information about the city they are in, and then there is a separate table with information about the cities themselves. And the idea with joins is exactly this, that you can connect two tables based on some field. For instance, in this case, the name of the city. And based on that, you can complement the data that you have in one table with additional details that you get from the other table. In this case, we are doing an inner join on an equality condition. So we are looking for all the records where there is a match, and the match must be on the value for the city on this table, matching the value for the city on the other table. But something that CrateDB supports, which is part of the SQL standard, but many people often don't see because other databases don't support it very well, is that this doesn't need to be an equality condition. You can write as complex of an expression as you want here. You can go on and say and something else or something else, greater than, less than, and also the two things, the things that you're showing, and there may be multiple joins here, don't need to be tables themselves. You can join views, you can join subqueries, you can join common table expressions, and very interestingly in CrateDB, you can join anything to anything. The joins are not restricted like in other systems to a specific kind of tables. So it doesn't matter where the data is actually living on the nodes or how many shards they have or anything like that. You can just take any data from anywhere and join it to data from anywhere else. And CrateDB figures it out automatically how to execute your query. Just wanted to explain for in case there is anyone in the audience that is just getting started, I wanted to explain briefly the difference between an inner join, a left join, and a right join. And to do that, I will use this other test environment with where I got a small data set where this can be seen more clearly. So on the power consumption table here, I got data for two cities. There is data for Berlin and data for Nice. And then I got another table with the details about the cities. But instead of having Berlin and Nice, here we got Strasbourg and Nice. So you see, there is a Strasbourg for which we got details, but we haven't got any consumption data. And there is Berlin for which we got consumption data, but we haven't got the details. And this means now that if we go to the query that we were running earlier, what we will see is that if we run it as it is with an inner join, we will only get the details for the city of Nice, which is the one for which we got details on both tables. So with an inner join, we only get data when there is a match. We can change this to be a left join, and this means that we give a priority to the table that is on the left-hand side, in this case, the power consumption. So in this case, we get the meter data for Berlin, even though there is no information about the region where it is, where the city is. We can also do the opposite, what is called a right join. And in this case, we get this additional line, which corresponds to Strasbourg. In this case, we were displaying the city from the power consumption table. So here I will need to add the city from the other table. And then you will see that the row concerns Strasbourg. So yeah, I hope that explains how it works. If it is not clear, please feel free to ask. We have posted a link on the chat with an interesting article that we wrote about how we have made optimizations to make joins a lot faster in CrateDB. And is a firmware we are always improving. So there are lots of optimizations coming with every release. It's getting faster and faster over time. So I mentioned briefly before that we can run subqueries, that we can have common table expressions. I just wanted to give you a quick example about that, again, on the environment with a lot of data. So here I just got a quick example of a query with a common table expression. And you can see here, just to get a flavor of the level of complexity that CrateDB can support, and it can get a lot more complex than this. But for instance, here we are looking at power consumption only on a specific city. We want to get the average of this variable for each meter ID in that city. And then we pick the 2 meters in Avignon that had the highest average global active power. Then we look up 2 meters and we get what's the minimum voltage. So you can see that there is a lot going on in there, but still the execution times stay very, very low, even though this is just a test environment with very low resources. So just to give you an idea of the kind of things that that can be done. Also, I wanted to cover very briefly window functions. We support all the usual window functions, so rank, dense rank, lead and lag. You can define the functions, so with all sort of partitioning, filtering, nulls or not. You got the full flexibility here. And again, this can be applied to data coming from anywhere, from data concerning all our complex data types. So you can deal with objects with arrays. You can be doing a lookup, full text search lookup. You can be doing nearest neighbor search lookup. So all sort of, you can combine all these features together, and it continues to work. It's not just something that you can use on specific cases. So this is maybe a bit difficult to explain briefly on a few minutes, but I invite you to take a look at this link that we will share in the chat, where this is explained in detail. And I just wanted to show you a very quick example running it live, so you can get an idea how this works. So here I got a table called devices.readings that has 120 million rows. And here I got an example of a query with the lag windowing function, and we can see that in just a few milliseconds we can dig into this data and see the delta in battery temperature between 2 readings very quickly. So these are the sort of things that you can do with CrateDB. And that's the end of my presentation. So let's see if we got any questions. Yes, so there is a question here. Rasha says, what kind of roles and access levels we have in CrateDB? Do we have a cluster level or even node level access for security? Yes, so we got very granular permissions model in CrateDB, starting from access and authentication, like Niklas mentioned on the previous module. So you can control at the node level where people can connect from over the network, over which protocol, if you want to enforce encryption, which user accounts are allowed to connect through that endpoint on that particular node. And then once people are already authenticated into CrateDB, you can limit them to have just read permissions, or you can allow them to modify data, but not make changes to the schema. There are very different levels that you can, and you can do this for tables. You can do this at the schema level for simplicity. You can also do it for views, which is very, very good, because by granting permissions on views instead of granting permissions directly on the base tables, you can enforce all sort of rules around to then get row and column level controls in place. So if you got certain users that should not see the data on certain columns, you can do that. If you got a multi-tenancy environment where maybe certain users should only see a subset of the records on a table, you can do that as well. And there are lots of interesting tricks and tricks that you can do around that. So yes, definitely we can do that. Another question that we got is if we could specify more than one column for a primary key. And yes, definitely we can. We just on the primary key, but we are instead on my example earlier, I just added the primary key keyword to the row for that column. But instead of adding primary key there, you just add at the end of after all your columns, you create what primary key constraint. So you say primary key parentheses, and then you can specify a list of columns, and they all work together, and the uniqueness is checked on the combination of fields. Yes, definitely. There is another question about what kind of open source ETL tools we recommend for CrateDB to ingest data from different sources. So you can use pretty much any tool that works with Postgres. So a lot of our customers use Airflow, which is very popular. You might have heard of it, but you can use whatever works for you, basically. We got several tutorials on our website. So one of the links that we shared earlier, there is a list of integration tutorials, and you will find several ETL tools in there in the list. And there is one more question about when will you use subqueries, when you will use joins, and this is basically about what is easier for you to write and to read. If you find that it's more intuitive to write a join, then go for the join. If you find the subquery is more intuitive, then go for a subquery. There are, in particular, some situations where trying to force one way or the other is quite artificial. Sure, you can translate between the two, but yeah, in summary, is whatever you find more readable or easier to write. The optimizer in CrateDB is getting better and better, so there is not necessarily any big performance implication there. Sometimes, like by doing things with the subqueries, you can kind of bring the optimizer to do things in a certain way. So in some scenarios, you may find a more optimal plan with a subquery, but in general, I would say you don't need to worry about that. Just go for whatever you find more intuitive. That's all for the questions. So maybe I will. But there is one more question. Yeah. How to configure the data type changes before we insert data from a CSV file into the tables? I am not sure exactly what the question is, but if you are importing from a CSV file, the CSV file doesn't carry metadata on the data types. So CrateDB will do a guess then based on the first value. If you haven't defined, if you're using a dynamic schema, you haven't specified the data type. That is where specifying the type in advance is convenient, because sometimes it's difficult to distinguish between maybe the first 100 rows go all integer numbers, but you know that at some point you get a number with decimals, and CrateDB will know that in advance. So if you know that the data you will be importing requires a float number, for instance, and you know that already, or or it may even be alphanumeric data at some point. So in that case is where you will create a table like I did in my example with a simple create table statement specifying the data types. And that way when you run the import, everything should fit in. Maybe I will invite everyone to come back.
Yeah, it seems that's all for the last Q&A. Thank you, Hernán. Very interesting presentation. So before we finish for today, don't forget, first of all, that we have another session tomorrow at the same time. There we will cover more advanced topics such as data modeling, execution plans, query optimizations. And in the meantime, I would like to invite you to try out CrateDB Cloud. So, you know, we have open source version that you can run on-premise in your own environment. But CrateDB Cloud offers a lot more on top of the open source version. And you also have opportunity to deploy a free cluster that is free forever without leaving any payment information. It has limited configurations, but it's excellent starting point to explore CrateDB capabilities and to maybe even try out what you have learned today. So thank you again for being with us today. In the meantime, if you want to talk to our engineers, there are two options. You know, the slides will be shared with you, and on this slide you can find a link to make an appointment with one of our engineers. And if you don't want to make one-to-one appointment, but you just have some questions about CrateDB and would like to share your use case, there is opportunity to join one of our office hours that we organize every month. The next one is going to be on 18th of October, so that's already next month. So if you have some questions and would like to share your feedback with us, or you want to share your use case, join one of these sessions in the future. Please also follow us on major social media channels, LinkedIn, Twitter, and GitHub. And if you also have some questions and you would like to join our community, we have a very vibrant and growing community where we also post all the relevant stuff around CrateDB, like new tutorials, new information, new releases, and new events. So with that in mind, thank you again for being with us today, and see you all tomorrow.